All right. How can I welcome you back? That's how. Welcome back, everybody. Welcome to another exciting morning, Chem 1211, with your host, me, Dr. White. I hope you all had a good time. Now, I'm not waving you goodbye. I'm saying, hope we all had a good time. All right. Couple things. First of all, uh, let me remind you, get your labs in. Some of you didn't turn in the lab that was due right before spring break as a special treat. Don't tell anybody I'm being nice. I'm going to open up the window so you can have till Friday or Thursday if you have Thursday lab, Friday for Friday lab, for last week's lab. But starting this week, you'll have a couple days to hand it in. After that, you get zero. I spent over the weekend a lot of time tracking down who was missing labs and letting them know. I'm not going to be doing that again. It's your responsibility to turn in labs on time. And it also helps your grade. All right. As you all know, by Friday or Saturday or Sunday, I forgot which now, last week, I sent back, first of all, I posted in Blackboard test number 2 scores for all of you. And I also sent you an email individually with your points for each question from test number 2. So hopefully you got that. What we're going to do right now is I'm going to go through test number 2 and I will be removing it from the video. If you have any questions about why I graded a something, come to my office hours or email me. Remember, there's no such thing as a dumb question in my class, in my universe, and therefore you can always feel free to ask questions. Why did I take off points? Now, before I start, if you had the wrong significant figures, like test 1 on test 2, I took off 1 point. So if you see I took off 1 point here or there, that was the reason. By the way, most of you did really, like almost all of you did good on that, which makes me happy. I don't know about you, but I like to be happy. And I don't know the exact average, but I want to say it was in the high 80s or low 90s. And for this test, that's good. All right. Everybody hear me now? Am I coming through glitchy or okay? Test 1, 2. I was just fooling with your brain. All right. We're back to normal, whatever that means. All right. Let's get going. Ooh, I forgot to call y'all back. Let's get going. All right. Last week, actually 2 weeks ago, not last week, you had the last week off, I started talking about solutions. So let's go back and do a little review. Thumbs up, people. Can you see solutions on? Thank you. All right, what's a solution? You should know it's a homogeneous, that means same throughout, combination of 2 or more substances, which each substance retains its own chemical identity. Now, I'm doing reviews, so you should know, we did this before break, that a solution contains a solvent, and that's the component of the solution that's present in the greatest amount, and a solute, or it could be also solutes, a solution component that is present in a small or smaller, or this should actually be smaller, amount relative to the solvent. So right now you're all breathing in air that has 80 parts nitrogen, 20 parts oxygen. If we took 100 grams of air, it would have 80 grams of nitrogen, 20 grams of oxygen. So in air, what's the solution? And hopefully all got nitrogen. And what's the solute in air? And that is oxygen. Most of the time, people think of solutions as being liquids, but it doesn't have to be a liquid. I talked about different types, gases, liquids, and solid solutions. Now, new stuff. Solubility of a solute. That's when I say the solubility of a certain solute, that's the maximum amount of solute that will dissolve in a given solvent. That's called the solubility. Thumbs up, people. You see sodium chloride on your screen? Thank you. Now, as I've said, I think I mentioned it more than once in here, when it comes to chemistry, Wikipedia has been so heavily policed by chemists, PhD chemists like myself. It's been a number of years since I saw a mistake. Yes, I have the credentials. When I ask for a change, they make it. But if we scroll down here, we can see right here in the lower right hand properties, and gives you the molar mass. It tells you its density, and here's the solubility in water. And that means you can dissolve up to 360 grams of salt, sodium chloride, in 1 liter of water total. And let's see the footnote down here. Usually they also give a temperature, but they don't. And here they give the solubility. I don't know who would need it, in ammonia and also in methanol. Notice that hydrogen bonds are really good to water. That's why it's so much more soluble. And this is the maximum amount, the solubility. Let's look up one more while we're here. And that's sodium fluoride. If you notice, they do give the temperatures at room temperature approximately. It's not as soluble, but still soluble in water, 40.0 grams per liter of water. And that's solubility. So solubility tells you the maximum amount of a solute that can be dissolved in a solvent, of a solution. And you should know this. And by the way, why did I pick sodium fluoride? Because that's put in your toothpaste and our water to help give you better teeth and less dental problems. Now, what can affect the solubility? Well, what are you trying to dissolve that solute into? The temperature, other solutes present, the actual solute you're trying to dissolve, and it's even the pressure. Atmospheric pressure sometimes will affect that. And remember, don't forget, everything you see on the screen here, except Dr. White, is available on Blackboard as a file. I'm available on YouTube, I guess, as a file too. a video file. All right. All right. The next two, I think, slides, I'm going to be giving you some definitions. If I had a dial, I could only turn up to 10. I just turned it up to 20. Yeah, you should know these. All right, when we talk about solutions, certain definitions you should know. The first one is a saturated solution. And a saturated solution contains the maximum amount of solute that can be dissolved under the conditions at which the solution exists. When you have a saturated solution, you can't put one more molecule, if it's molecules is your solute, of that solute in the solution. If you do, it precipitates out. You all know what a precipitate is. That's solid in a solution. So you can only put, that's the maximum. When you have a saturated solution, you have the maximum amount of the solute that can be dissolved under the conditions, meaning temperature and solvent, this at which the solution exists. Next, a dilute solution. A dilute solution, the hint, you should know this, is a solution that contains a small amount of solute relative to the amount that could dissolve in that solvent. So dilute means a solution, you have a very small amount of whatever the solute is in that solution. Hold on, let me see if that's the president. Two more rings and it will stop. Can you see the fancy lights? Oh, they stopped before. All right, so dilute solution, you have a small amount of solute relative to what you could dissolve in there. By the way, I should warn you, bartenders don't like being told, did you just make me a real dilute drink? In other words, they watered it down. They don't like being told that. Now, the opposite of dilute is a concentrated solution. And a concentrated solution, again, this is another one I should have written on the previous slide. So hold on while I back up, because I don't want to cheat you out of your hints. So dilute solution, you should know, contains a small amount of solute relative to the amount that could dissolve. And the opposite of that is a concentrated solution. Oh, it even says, know this, and you should. And a concentrated solution is a solution that contains a large amount of solute relative to the amount that could dissolve. It's not saturated, but you're getting pretty close. Remember, saturated is the maximum amount. So a dilute solution contains a little, concentrated contains a lot. All right, thumbs up, people. Let me see if I did it correctly. Do y'all see the concentrated cans of orange juice on there? Well, why do they call it concentrated? Because the orange juice, not the water that's in there, a lot of it has been removed when they make that to make it concentrated. And that's why they call it a concentrate, because it is concentrated. Now, are you ready for an interesting Dr. White story? When I was an undergrad in our fraternity, we had a lot of characters, including Dr. White. And one of my fraternity brothers, oh, it still goes like this to make me think about it. He used to love in the summer to eat with a spoon concentrated orange juice right out of the can, still frozen. Yeah. Dr. White's not a big orange juice fan either. But anyways, I can still remember years later him sitting there eating his concentrated orange juice. Mm. Now, one that's very important, everybody get the hint? By the way, I charge extra for kids coming to my class. Hi, Zoe. But anyways, you should know that an aqueous solution tells you that it's a solution in which water, H2O, is a solvent. Aqueous comes from Latin aqua, or water. And you should also know that is abbreviated by AQ, bracket AQ, close bracket. And this tells you you have an aqueous solution and the solvent is water. So, and many things in our life, solutions we use, water is the solvent, but not all of them. So let's go back and look at these real quick again. Saturated solution, that means you have the maximum amount of solute that can be dissolved under the conditions in which the solution exists. You can't put any more in there. Can't put one more molecule if it's a compound, one more atom if it's atoms to dissolve. You're at the limit, period. If you put any more, it won't dissolve, it will precipitate if it's a solid and stay at the bottom. Speaking of that, when I was in grad school, to clean up samples of things that were in ether, you used to mix it with a saturated solution of sodium sulfate. And I used to make, every Monday morning, I'd make about a gallon of saturated sodium sulfate for me to use during the week. Dilute solution contains a small amount relative to what you could dissolve. And if something's too strong, add water because you're diluting it. You're making a dilute solution. There's less solute per given amount. Concentrated solution, you have a large amount of solute relative to the amount that could dissolve. You're not at saturated, but you're getting close to it. And finally, it says hint, really know this, and you should. Aqueous solution. That's a solution which water is the solvent, and it's abbreviated by bracket AQ, close bracket. Now, another one, I'm not going to ask you, non-aqueous, that's where the solution, which is substance, is a solution which the substance other than water is the solvent. And you better hope the gasoline you bought was non-aqueous. You don't want any water in your gasoline ever. Now, I'm going to turn the switch off. Hold on. Click. Will this be on as test or final? No. but there's a few things I want to talk about just to give you a feel for it. When you make a solution, say if you take some sugar or salt and you mix it in a bottle of water or a container of water, what happens? You have different interactions to begin with. You have solute. That's what holds the salt together in a solid. You have the solvent that's interacting, hydrogen bonding if it's water, and those are overcome, and then you make new interactions between the solute and the solvent. So if I were to take sodium chloride and put it into a container of water, well, the solid first is in there, and the water's in there. When you stir it up, you make new interactions, you overcome old attractions. Again, switch is off for this. Now, switch is still off. What affects the rate of solution? Well, are you putting in big boulders or very fine powder? That will make a difference. How fast are you? How much energy are you doing when you're agitating it? And it's called mixing. And finally, what temperature? Many things, not all, but many, when you increase the temperature, it dissolves quicker and you can get more in. Example of that is, how many of you ever dissolve sugar and water to make like a sugar syrup for cooking? And the easy way to do it quickly is you take your pot, put it on the stove, put your water in there, put your sugar in there, turn on the flame unless you have electric, turn on the heat and stir it, and it goes right in, and a lot quicker than if you just have cold water and sugar and you stir it, you're going to be there a lot longer. So temperature in many cases plays an important role. Again, switches off. All right. If I had a switch that only goes to 10, I've just turned it up to 100. Yes, 100. The next thing I'm going to teach you is something important. And guess what? It is something good to know for your everyday life. And that is the rule of thumb, like dissolves like. A rule of thumb means it's almost always true, but not 100% true. And like dissolves like, what does that mean? It means substances of like polarity tend to be more soluble in other substances that differ in polarity. I'll explain polarity in a second of compounds. Know this, like dissolves like. This is a generalization, otherwise known as a rule of a rule of thumb. I'm saying it wrong, but anyways, it's not a law. This should be it's true with ionic inorganic compounds. And consider polarity of medicine. All right, let's go over some things. When we talk about polarity, there are two types of substances, polar and nonpolar. And you should know this. Sorry about it, I didn't write it, change to red, but you'll get the message. Now, what are polar things? The most important is water. Water is the most polar compound in our universe. Nothing more polar. Everybody see that on their screen? Thumbs up, people. Next, ionic compounds, salts, are polar. Alcohols, if you're an organic chemist, ethanol, rubbing alcohol, and example of an alcohol you don't think about are sugars, are ionic. Now, let's look at nonpolar compounds in our daily life. Well, gasoline is nonpolar. Ooh, Vaseline, otherwise known as petroleum jelly, is nonpolar. Baby oil is nonpolar. Vegetable oil is nonpolar. And guess what? Dirt and grease are nonpolar. What like dissolves like means is if I take water, what can I dissolve into that? Things that are polar. If I take water, things that are nonpolar will not dissolve in that, and vice versa. If I take gasoline, it will be soluble in things that are other nonpolar. Now, interesting thing happened a number of years ago now in a Chem 1, 1211 class, and I'll put that list up in a second. I had a really clever student, and before I do that, let me ask you, how many of you have ever seen a bottle of oil vinaigrette dressing? And if you let it sit for a while, you see 2 layers. And if you shake it up, you put it on your salad, then you put it down, it separates the 2 layers. I'll bring back the solubility in a second, Marissa. Don't worry, I will. And why? Because oil vinaigrette, like my mother loved wishbone, I've learned how to make much better than what you buy. Anybody wants, come to my office hour and I'll give you the recipe. But anyways, why does it separate? Because I had a brain freeze, a rule of thumb, like dissolves like. In oil vinaigrette, you have vegetable oil, and vinegar is essentially water and a compound called acetic acid. It's really just mainly water. Well, water is polar, vegetable oil is nonpolar. Like dissolves like tells me they're not going to dissolve and make a homogeneous solution. And they don't, and that's why they separate. And let me go back to the solubility rules. Like dissolves like, which is a rule of thumb. That means it's true about 95 or more percent, but a law is 100%. This is not always true, but most of the time it is. And it means substances of like polarity tend to be more soluble than in each other than other substances that differ in polarity. A better way of doing that, polar things are soluble in polar things, nonpolar things are soluble in nonpolar things. You mix the 2 together, they're not soluble. I'll say that again in slow motion. Like dissolves like, polar things are soluble in other polar things. Nonpolar things are soluble in other nonpolar things. And if you mix polar and nonpolar, they're not soluble. Does that help? Now, if you look at this list, you're welcome. If you look at this list, uh, like I said, I had this really sharp 1211 student, and I've got a lot of sharp ones in this class too. And in a lecture, this is when we were face to face long ago, he said, Dr. White, does that mean if I have vegetable oil, is Vaseline soluble in vegetable oil? I told him, I don't know, I've never tried it. I'm a chemist. We do experiments. Next time we're in a lab, I'm going to get you some vegetable oil and Vaseline. Do you mind mixing the two together in front of the class in the lab and see if they're soluble? And he said, no, I don't want to put people on the spot if they're not comfortable getting in front of a crowd. But anyways, so next lab, I got from the stockroom some vegetable oil and we had Vaseline. And I gave it to him and said, in a beaker, put a little of each, take a glass stirring rod and go like this. And lo and behold, the Vaseline dissolved the vegetable oil. Now, why you'd want to do that, I don't know, but like dissolves like, a rule of thumb. Oh, it's on this thumb today. Can you see it? Works. Now, how many of you have gone into a gas station after a rainstorm and you see these puddles? When the sun comes out, you see the rainbow on top of the puddle. Have you ever seen that? What's happening? Light dissolves light. Gasoline is not soluble in water. They separate. Don't try this at home. But anyways, if you're ever in a gas station, you can always see people are sloppy with their pump. And then they take the nozzle out. They don't always try and get the last drop out. So that some gasoline might go underground. And when there's water, it's going to go on top and separate. And when the sun comes down, because the difference in refractive index, and I don't know why my screen's going in now, I think because, I don't know, say Friday the 13th. Well, anyways, oh no, it's Monday the 5th. That explains everything. But anyways, the difference in refractive index caused the light to separate into the rainbow. So next time you go into a gas station, you see puddles of water and the sun is out, you can see the rainbow on top like a film, you can remember light dissolves light. I'm writing on my whiteboard, hang in there. All right, let's look at the following. And I better translate this for you, for those who haven't figured out my handwriting yet. Let's look at the following. 5 points. Compound Z is soluble in vegetable oil, but is not soluble in water. What's the polarity of compound Z, and how do you know that? And I'll let you try that, and then I'll do it. I tried polling. All right, I think everybody's done. Let's do this. So the question is, compound Z is soluble in vegetable oil, but not soluble in water. What is the polarity? Well, if it's soluble in vegetable oil is nonpolar. It's not soluble in water, which is polar. So like dissolves like tells you, because of that, and you know that because the like dissolves like. And that's an important thing. Now, it turns out like dissolves like plays an important role in our daily life. And there's certain compounds that are surfactants. And surfactants are long molecules that have one part is nonpolar and another part is polar. So they can interact, one part of the molecule can interact with polar things, the polar end, and the other part nonpolar. By the way, click switches off, but I thought I'd show you something important. And surfactants help overcome this. What's an example of a surfactant? Soap. The next time you wash your hands, or you take a shower or bath, or shampoo your hair, or do your dishes, or even do your laundry, you're using like dissolves like and a surfactant that can interact in both with polar and nonpolar things to clean whatever you're trying to clean, like your hands, your dishes, your car, your clothes. But you didn't think washing your hands was chemistry. It is. It's actually sophisticated organic chemistry. So next time you wash your hands, hopefully you're doing it a lot now with the pandemic going around, you're doing chemistry. Like dissolves like. Let's assume we were in a lab together face to face. I asked one of you, hey, could you mix some salt and water, make me a salt solution? At the same time, I walk over to another student and say, hey, can you mix me some salt and water and make me a salt solution? Well, will they taste the same? Probably not. Why? Because one student could put more salt in a given amount of water than the other, and they'd be different. Well, how do we make sure that doesn't happen? And chemists use a concept called concentrations. Now, concentration is the amount of solute present in a specific amount of solution. And I'll never ask you what's concentration, but I'll use that concept. So concentration of a solution tells you how much of solute is present in a given amount of solution. Again, I'll never ask you this definition on a test, but I'll use that term. Now, there are three different ways of measuring. Where the slide disappeared from here. Sorry about that. There are three different ways of measuring concentration. The first one is percent concentration. And percent concentration deals with, also known as percent by mass. And here you have mass of solute per mass of solution times 100. Now, I'm going to have the switch off for this because I'm not going to ask it on a test. But percent concentration or percent by mass plays an important role, and you should be familiar with it. The higher that number, the more that solute is present in a solution. Where does this play a role? Well, I'll give you an example. When I first bought this house that I'm living in, I bought it in, I think, August. And I went out Saturday morning to mow my lawn for the first time. I was all excited, my nice new house, nice lawn. And I was doing it for about 5 minutes and I stopped. Why? Because I started getting eaten alive by the mosquitoes. So I put my lawnmower away and said, all right, I need a repellent. So I went to the local big box store, which closest one. I went to Walmart. By the way, I only go to Walmart about 5 times a year. I try and stay out of there. But anyways, but I do the same thing with Costco. Both are dangerous places for me to walk into. And I went over to the area where they had mosquito repellent, buy the hunting and fishing supplies, for outdoors. And they had a couple of products on the shelf. One was a name brand off, and the other was this was the Walmart brand. I forgot what they call it. But anyways, I picked up 2 bottles. The off was much more expensive, and than the Walmart brand. The Walmart brand gave you about 20% more product in the bottle and was cheaper. I said, I wonder what other difference. So I looked at the label. It's something you can do. You learn what's the active ingredient. In this case, it's called DEET. DEET is an acronym for diethyl tulamide. And it's the molecule that mosquitoes don't like. Doesn't kill them, but for some reason they don't like it. I'm not a biologist or insect person, so I don't know why they don't like it. They never told me, but anyways, they don't. So I look at the bottle. The more expensive name brand had about let's say 2.2% G. The Walmart, which they gave you more and it was cheaper, had 4.2% D. I'm saying, well, I know what I'm buying. I'm buying the Walmart. It's less expensive and they give you more of the chemical that will give you protection from the mosquitoes. How do I know that? Because Dr. White understands percent by mass or percent concentration. And that means there was more of the solute, in this case, the DEET, for the solution mass, and that's a percentage. And this is how they calculate it. So it was how many grams of DEET per 100 or whatever times 100. Now the mass of the solution is the mass of solute plus the mass of solvent. And again, switches off in terms of this being on a test or a final. Ooh, that reminds me. A couple of years after I moved in the house, there's this one part of my foundation has a very minor crack. I've tried patching it, and if we have real heavy rain, it will ooze just a little water out of it, nothing dangerous. But a couple of days it starts smelling moldy. Dr. White is an organic chemist who's worked in the industry, chemical industry, and one of the areas I worked in was antimicrobial compounds, making them. They're called quaternary ammonium salts. So how many of you have seen the spray can you can buy to get rid of mold and mildew? So I just happened to go over to a Walmart again. No, I don't live in them. But anyways, and I go over to where they have these cans. And again, there's a name brand and their brand. And I pick up the can, and Dr. White knows you look for the quaternary ammonium salt that's in there. That's what kills the mold or the mildew. It gives off that odor I don't like. And I picked up, they're the same size can, same weight, and they're spray cans. And I think it was Clorox, uh, had so much of the quaternary ammonium salt, and the Walmart had a lot more, and they were the same price. You know which one Dr. White bought. Yep, the Walmart again. And so it pays to look at labels, and now you know. And if you look at some of your medicine or creams you put on over the counter and all that, you can see the ingredients and how much. Now, if they don't list the amount, the closer to the beginning of the label, the more of that's present. But for a lot of things, like I just mentioned, you will see how much of the active ingredient, and it'll be a percentage. Switch is still off. And another way of determining concentration, how much of a solute is in a certain amount of solution, is percent by volume. And this percent by volume, again, the switch is off, is volume of the solute divided by volume of the solution times 100. I don't have here, but volume of the solution is volume of the solute plus volume of the solvent. And the only place I really see percent by volume is in wine. If you go and pick up a bottle of wine, by the way, Dr. White loves his German wines, white wines, because I worked in Germany, and the Pierce Porter, Golden Trocken wines are the best, much better than any French white wine. But then I'm biased because I worked in that area and had enough of it. Boy, do we have enough of it. Chemists know how to party hard, especially when you're doing it on the company money. When you're a senior manager, they pay for all that. But anyways, if you look at a bottle of wine, it will have percent alcohol by volume. And the higher the percentage, the more alcohol it is, and the more you got to worry about drinking too much before you think about getting inebriated, which I'm not in any way suggesting. And that's about one of the few places I've seen that I can think of off the top of my head. Anything more up there? But anyways, off the top of my head is percent volume. Again, switches off. The final one I like to talk about is molarity. And molarity is probably the most important concentration in science and chemistry. And molarity, which is abbreviated by a capital M of a solution, is a ratio giving the moles of a solute per liter of solution. And you should know molarity, it's even on the slide, is equal to moles of solute per 1 liter of solution. Molarity, moles of solute per 1 liter of solution. And that's called molarity. And we use it all the time in the chemical industry and in academic and teaching labs. And I'll explain why today, or if not today, on Wednesday. Now, remember, 1 liter equals 1,000 milliliters. Therefore, molarity, moles per liter, is also moles per 1,000 milliliters. And here, the liter and the 1,000 is an exact number because it's part of a definition. All right. Thumbs up, people. Can you see, hint, know this? Molarity? You should. Molarity, by definition, is moles of solute. Now, nobody uses 1 liter in the lab because you're going to be measuring out milliliters per 1,000 milliliters of solution. So molarity, moles of solute per 1,000 milliliters. And we use capital M to denote that. So if I were to write the following, what does this mean? And you see 1.55 capital M NaCl. And what does that mean? 1.55 moles sodium chloride per 1,000 milliliters, or 1 liter, but in the lab we use 1,000 milliliters. Remember, capital M tells you molarity, and molarity is moles of solute per 1,000 milliliters of solution. I better share the fun. What does this mean? 2.71 capital M HCl. Your turn. And when you're done, give me a thumbs up. Everybody done? I guess so. All right. As soon as you see capital M and a chemical formula afterward, that means molarity. Molarity, moles of solute per 1,000 milliliters. So what does this mean? 2.71 moles of HCl per 1,000 milliliters. Let's do another one. All right, what does this mean? And what is the solvent of the solution? I'll do this one. Capital M tells you molarity. Molarity, moles of solute, in this case H2SO4, sulfuric acid, per 1,000 milliliters of solution. And you could have put a liter, but you'll see why this is more important. Now, what is the solvent of the solution? And the AQ in a bracket, aqueous, tells you solvent is water. So if you go into lab, you'll see bottles of what we call stock solution made up like that. Oh my goodness, I just looked at the clock. Time flies when you're having fun with solutions. And Dr. White. All right, we'll continue this on Wednesday. Don't forget tonight, I have my office hours. If I misgraded your test, email me and I'll change it by Wednesday at the latest, hopefully, unless someone gives me $1 billion, then I might be a little later, but I'll get that done. And don't forget, Thursday or Friday, depending which day you have lab, I will go through the gas problem set, chapter 11, and I'm going to do a little Be Nice by Dr. White. If you didn't, the lab done right before break, you didn't hand it in later today or tomorrow morning. I'll change the window so you can hand it in if you didn't. And the other thing is that lab, and I'm caught up with all the scores of all your labs you've handed in Blackboard. So check. I sent out emails, some people who I had trouble, where you had trouble uploading it, and Blackboard shows me a little blue sign. With that, I'm going to say, Gang gesund, goodbye. I'll see you on Wednesday. Bye now.